Okay, for the purpose of time, I think we'll go ahead and get started. Welcome, everyone. My name is Gio. I am the technical sales lead here at Voltera, and today I'll be your host for our very first webinar of 2025. The focus of our webinar today will be printing multi-layer, flexible, and stretchable circuits using our new software program called Plan. The agenda for today is as follows. First, we're going to go over an overview of Plan and how this new capability unlocks multi-layer printing. Next, we'll go into the key capabilities of Plan, including multi-layer printing and print job editing. And then finally, we'll jump into a live demonstration of the Plan feature. I'll be walking through the Plan software as well as through a dispense workflow on Nova. And finally, we'll leave some time for some Q&A towards the end, where there will also be a discount code for Nova where you can receive $2,000 off a Nova purchase. Another quick note here is that we do have my colleagues Bill and Matt in the chat, or in the Q&A, I should say, to answer any questions that come up throughout the presentation. So just click on the Q&A button below your screen to ask any questions that may come up. Okay, so first an overview of Plan. So Plan is a new feature designed to unlock advanced capabilities within Nova that include multi-layer printing and print job editing. This will be an essential tool for users that want to print multi-material designs, so designs that may include materials like copper, silver, dielectric materials, and how those layers might stack up against each other, more control over the printing process, and finally, reduce setup time for repeat prints that you may have planned throughout the week. The first key capability that we're going to jump into is multi-layer printing. So users will be able to set up multi-layer workflows with one step by adding multiple layers into Plan. They'll be able to visualize how these layers stack up against each other with the ability to change the order. They'll also be able to generate smart probe points to adjust for layer height changes between the said layers. And finally, create efficient height mapping for faster processing. Another key capability is print job editing. So users will be able to visualize toolpaths and probe points for quick iteration. Reorder feature for consistent results. An example of this would be, instead of printing left to right, we can print right to left. Remove unnecessary elements like specific traces or probe points, and save and reuse settings for easy and consistent reprints. So now that we have a quick overview of what Plan can do, of course, it's always better to take a look at it and see what this actually means. So we're going to jump into the Nova software and go through a workflow within Plan. So just switching over to the Nova software, I'll zoom in on this so we can see this a little bit better and clear. So this is the Nova homepage within the Nova software. You can see in the center of the page that we have four main functions. We have our dispense workflow, our materials, our calibration process, and Plan. It's important to note that Plan is currently in beta and does require an internet connection to be used. And we've labeled the beta tag there underneath the Plan title. So for today's webinar, we'll be focusing on two tiles, Plan and Dispense. But first, we'll jump into Plan. Sorry. Okay. So when you open up Plan, a welcome bubble is going to pop up, indicating the steps and features of Plan and how it should be used. So it will give you a walkthrough step-by-step of loading your design files, generating your tool paths and probe targets, features like editing probe targets, as well as another feature like editing toolpaths. And then finally, the final step, which is to save your project and move on to the dispense workflow. So this will be very important for users that open up Plan. It's always great to read through this, but of course, I'm going to show you all this as well right now. So the first thing we're going to do is we're going to load a new Plan file. So we're going to hit New and choose the files that I've selected for this specific demonstration. So today we'll be looking at a 3-layer print or design. And you can see that my 3-layer design, once I've loaded the files and hit Continue, will populate in the center of the print bed. These specific layers are also highlighted on the left-hand side of the screen where you see print order. So I can go through each specific layer and look at them individually. This is also where I can rearrange the order. Rearranging the order is done by simply clicking and dragging the specific layer to where I want it to go. For the purpose of the demonstration, we'll leave it as I loaded it in. One other feature of the print order is that we can open up each specific layer and look at the polygons and or polygons or features within that specific layer. So to better visualize this, we'll hide layers 2 and 3 using the I button right here, so we can just focus on our first layer. So as I scroll through the first layer here, I can see that each polygon highlights a specific feature within the layer. And I can also hide these as well if necessary. I find when you're working with multiple layers, it is a little bit easier to look at it layer by layer. So as we're going through it, we'll go one by one. So once we click on this first layer, highlighted by the blue image here, we can move over to the right-hand side. And we see 4 other tabs: Display, Toolpaths, Probe Targets, and Color. So you can see that we have some exclamation marks here next to toolpaths and probe points. This indicates that we need some work to do on these specific tabs before we can move forward and save our design. So we'll go ahead and open toolpaths. So toolpaths are what is the workflow in which Nova will take to complete the specific design. We generate our toolpaths based on a setting called trace space. Trace space is the center-to-center distance between 2 parallel paths. So the default trace space that we see here is 180 microns. So we'll go ahead and generate those toolpaths based on the default setting. Once I do that, the generated toolpaths for each polygon will appear underneath. So focusing on the actual print, if I click on it, I can now zoom in and I can actually see the white lines, which indicates the toolpaths that our dispenser will take to complete the specific design. You'll also notice that there are 2 dots, a green dot and a red dot. The green dot indicates the start of the workflow for this specific feature, or the point at which Nova will start dispensing, and the red dot indicates the end. These can be swapped simply by hitting the arrows that you see on the right-hand side underneath toolpath or next to your toolpath. And when I hit that button, you'll see that the green and red dot have switched places. Once again, indicating that the workflow will start from here and end here. This can also be done for each individual feature or polygon within your toolpath, or you can reverse them all at the same time. For the purpose of the demonstration, we'll leave it as it originally was. So from here, we have a couple other options for trace editing that we can look at. So we can actually add additional traces from the start point and the stop point simply by clicking on the green dot and dragging this. This now changes where our specific trace is going to start and has extended the workflow. And if for whatever reason that doesn't need to happen, all we need to do to delete this is simply click and hit delete on your keyboard. So this will come in handy if there are specific features or traces that you may not want or need as you generate your specific toolpaths. On the layer number 2, we'll dive into the toolpaths a little bit in more detail to understand how the different trace spaces could affect how Nova dispenses. But before we do that, we'll move on to the next exclamation mark that we see here, which is probe targets. So Nova uses a physical touch probe in order to map the Z height or create a height map of the substrate and the layers that we'll be printing. So the way that it's mapped is by setting up probe targets. So we're going to go ahead and generate the specific probe targets using what we call our probe pitch. Probe pitch is the maximum distance between 2 probe targets. So currently the default setting for probe pitch is 5 millimeters. And we can see here that these specific probe targets have been generated to height map this specific layer. Now, if we want to decrease our probe pitch, for example, if we move it to 2 millimeters between each probe points, this will generate more probe targets, indicating that we'll have a higher accuracy height map. This will become important as we print layer on top of layer because we want to account for additional height changes throughout the layers that we're printing. So a the smaller your probe target is, the more dense the probe points will be, but you'll have a much accurate height map as you're working through. This will also take a little bit longer to probe, but our design today is quite small, so we don't need to worry too much about that. So I'll leave the probe targets as they are here for the layer number 1, and then move on to layer number 2. Oh, one thing I did forget to mention, that you are able to actually look at each specific probe target throughout the menu that you see here. So if, for example, you needed to look at this specific probe target or this one and actually remove them, you're able to delete them simply by hitting the trash can button on the right-hand side. And finally, as we're scrolling all the way through, we can see that the last step here is color. So color will just indicate more of an aesthetic feature that can change the color of your specific layer. This will become handy as you're working through multiple layers. You can clearly identify which layer is which by using the color portion. So we'll move on to the next layer and set up that one. As you can see, we'll unhide it as well, of course, and we'll hide the first layer. As you can see, the same thing happens on the right-hand side where our toolpath and our probe target do need to be generated for this specific layer as well. So we'll go ahead and generate the toolpath like we did in the previous layer. So as you can see, the white lines have populated once again, indicating that this is the path that Nova will take to complete this specific design. Now, as I mentioned earlier, if we increase or decrease the tool space, the trace space, this will change the way that Nova dispenses this specific feature. For example, if we go ahead and hit 165 trace space and generate those toolpaths, you'll see that more toolpaths have been added to fill this specific feature. This will become very important when you decide on your material and the nozzle diameter that you're using. A good rule of thumb that we like to say is that your nozzle diameter should be close or slightly less than what your trace space is. Having too large of a nozzle with a tighter trace space could result in too much material being laid. And then the opposite effect of that, having a nozzle diameter that is too low and your trace space is quite large, could result in not having enough material laid. So it's very important to understand the nozzle diameter that you're working with, the material, to set a proper trace space as well. We're not going to focus on reversing any of the start or stop points here, but we are going to go ahead and move over to the probe targets and generate these specific points. Now, when generating the probe targets for the second and third layer, it's important to see how they stack up against the first. So we'll go ahead and unhide the first layer to see how they intersect with each other. One of the great features of Plan is that it understands that a first layer is being printed and this layer is going on top. So it's going to allocate more probe points to intersecting areas, as you can see here, here, and here, to account for the layer height changes. That being said, because this is the second layer and I do want my print to be as accurate as possible, I'm going to lower this probe pitch once again, down to 2. So as you can see, more probe points have been populated to account for the height changes once again. And I feel pretty confident that that'll be enough probe points to move forward. Next, we'll move on to our third layer. Unhide that as well. Generate the same trace space that we had before. Once again, have a focus on probe targets. We'll generate these probe points as well. And you can see that based on we'll hide the first layer just to make this a little bit easier. But based on the second layer, there are additional probe points where this specific layer will intersect with the second layer. Once again, let's move that down to 2. So we can have a tighter probe pitch and a more accurate height map as we print layer over layer. So as you can see, we now have check marks on each specific layer, indicating that we've set our toolpaths and our probe targets. We also have a check mark at the top, indicating that this job is ready to be printed. We'll just give it a quick title and hit save, which we can see here. There are a couple other icons at the top here. This one is your load plan folder. So these will be all the jobs that you've saved previously or as you work on them, and they'll all save into the plan software. This button here will just be a new workflow or start a new plan. And then this button will take us back to the main Voltera software. So we're going to go back and head to now the dispense workflow now that we have our job saved and ready to go. Once again, we'll go back to the main menu and we'll hit the dispense workflow. From here, we're going to load our job. And we're going to select the layer that we're printing. For the demonstration today, I've actually already printed the first layer, and we're going to be working on focusing on printing the second and third. So we'll go ahead and hit the second layer here and hit next. As you can see, the second layer has loaded into the center of our workspace. And once again, we can see the tool paths. And one important note, you will have noticed that there were fiducial points for each specific layer. This becomes very important when you're aligning your designs, as the fiducial points will help us to align each layer over one another. So it is important to include these for multi-layer designs. Next, we're going to choose our ink. Today, we'll be working with a demonstration material, a paint that we use for our webinars. So we'll go ahead and move forward with that. And we'll choose our substrate as well, which is actually going to be a sheet of polyimide. So from here, we get instructions that we need to mount the vacuum. Because we're using a thin film like polyimide, we're going to use our porous titanium vacuum table to mount the specific substrates. And one thing you'll notice as we're going through the workflow is that Nova does give step-by-step guide as to what to do in that specific step with video instructions. So we're going to go ahead and do that. So first, we're going to go ahead and load our porous titanium table or vacuum module. The vacuum pumps for Nova all live within the system, and there is no external power supply needed to power the vacuum. And then finally, we also have our sheet that we'll be printing on. You can see that our design, and we'll get a closer zoom on this, but it is in the bottom left-hand corner here. And then before we move forward, a few other things to look at would be this piece here in the top corner, which is our module hub. This is where our two modules, our dispenser and our physical touch probe will live. And then at the bottom here, we have a calibration area. This is where we'll calibrate our material and make sure that the ink is flowing properly out of the nozzle. And then finally, we have our XYZ switch here, which helps our tools find its positioning. So from this step here, the vacuum will turn on. And we'll hit next. Once again, if there are any questions throughout the presentation, the Q&A button is below, so please feel free. Our team is there, Matthew and Bill. They'll be there to answer any questions. So the first step we need to do here is to set our alignment. And the first step is to set the pivot point. So the pivot point has been automatically generated for us, as you can see, indicated by this specific point. We're actually going to leave that pivot point because we are going to be moving this design to the bottom left-hand corner to properly align. Next will be to set our pivot position. So we actually want to move our design in the X and Y direction. But before we do that, our camera needs to center itself on our XYZ switch, and then it'll move over to where our current pivot point is. So this will just take a minute for that to happen. We'll also turn on the LEDs here for a bit better light. Okay, fantastic. So the camera has reached the pivot point, and what we see here too is our augmented reality overlay of the current design that we're printing. So this helps us easily align to the existing layer as we're about to see. So there's a couple different ways that I can move this design in the X and Y. One is to use the arrows that you see on the left-hand side. This will move it in increments of millimeters, and we have 5, 1, 0.5, 0.01, and 0.02 for very fine adjustments in the X and Y. But since we need to move it drastically to the bottom left-hand corner, it's easier just to click directly onto the print bed using the little window in the bottom left-hand corner here. So we'll go ahead and click here. and we can see our design there. From there, I'm going to set up this point in the center on top of this dot simply by clicking on it. And now we can see that the fiducial of the first layer is matching that fiducial of the second layer and aligning our print properly. I'm just going to go ahead and focus the camera really quickly as well. And then we are going to just make some very small adjustments here just to center that fiducial point right there. And I can also see the one above indicated here, and that's telling me that I have a pretty, both are zeroed in right on the center, and I'm good to move forward. There is a third step here, which is called rotation. This would actually rotate the design if necessary, but that's not needed for this specific step at this time. Next, we have the tune alignment portion. So this would be very helpful if our design was quite large. What would happen is Nova would take photos of the entire work area, and then we would be able to set smaller adjustments within the work areas of the photos that were taken. But because our design is quite small, that's not necessary at this time. So we're going to go ahead and hit skip. The next step here is to mount the touch probe. Once again, instructions are given on how to do that. And we also want to ensure that our calibration plate is clean. So I'm going to go ahead and mount the touch probe on our module hub. We use kinetic coupling and SPI communication for the module hub and to connect to our modules. So that is a fully installed touch probe there. And the last step was to make sure that the calibration plate is clean so that there's no existing ink here. If not, we'd want to clean that up. And this is clean, of course. So we can go ahead, head back to the software, select that the calibration plate is clean, and we can go ahead and probe. So the zoom camera here will show the touch probe coming into contact with the XYZ switch. It'll then move over to probe the calibration area because we will be printing here, and then it'll also probe our design as well. It looks like we have some questions in the Q&A as well. So somebody asked, what is the purpose of the probe targets? How do they help the print plan? Matthew answered, the probe target indicates where Nova will measure the height of the substrate. This is important because we are printing very close to the substrate, around 60 microns and above, sometimes even lower, depending on your material. Another question that was asked was, one, how flexible is Nova for upgrading the nozzles with custom designs and customized inks? And two, any limitations for the substrate in terms of rigid or flexible, not PI, but elastomer and hydrogels? Bill was able to answer this question. The first question was answered by Nova is compatible with nozzles that use a lure lock, and we do provide empty cartridges to work with custom inks. Yes, we do have a variety of nozzle diameters available on our store, ranging from 50 microns all the way up to 410 microns, depending on what your material requires. And then the answer to the second question, there are no limits to the substrates that you can use with Nova. We do have options to work with flexible and rigid substrates. Hydrogels can provide a challenge due to their compressible nature. As we can see, Nova is going through the specific probe points. And if we quickly go back to the software, we can see that the probe points were generated for that specific design, and they're being highlighted as they're being measured. You also get a progress bar within the software indicating how long the probing might take. So that's going to finish up quite quickly here. Once again, our design is quite small. And we'll head over to the next step, which is to prepare a dispenser. Now, for the purpose of the demonstration, I've already prepared the dispenser to save time, but we do give clear instructions on how to assemble the dispenser, disassemble the dispenser, and clean our pressure sensor. Our pressure sensor plays a vital role within the dispensing technology, and it's how we're able to print most, if not all, screen printable materials or high viscosity materials. So it's important that as you're swapping through materials, that you either use a different pressure sensor or you clean out the current pressure sensor that you were working with. So there are instructions on how to do all of this throughout this menu. Once you've prepared the dispenser, it can go ahead and be put onto Nova, which is what I'll do now. So we just have that right here. So this is our dispenser. We have our cartridge ready to go in the center here, and we have a 150 micron nozzle, straight barrel nozzle that we're using to print the specific design. So the next portion of the workflow here is to do a flow check. So a flow check, as I mentioned a little bit earlier, will utilize the calibration plate to print a series of lines. Each flow check prints 3 lines, and it's a great way for us to just ensure that material is flowing properly through the nozzle. So we're going to go ahead and hit check, and that'll prompt the dispenser to come into contact with the XYZ switch, and then we'll see it dispense the 3 lines onto the calibration plate. Looks like we have a few more questions that have been answered as well. One question came in: Can Nova print on soft materials like resin? If I bend the material after printing, will the conductive traces still work? Matthew answered, yes, printing on flexible and bendable substrates is possible, but would be ink dependent. There are specific inks that are designed to stretch and flex. That is correct. We do have a variety of inks available on our website from certain suppliers that we partner with. We have items like stretchable silver, stretchable carbon, flexible silver, and flexible carbon. So depending on what your application is, the substrate that you're using, there may be a material that's better suited. Another question that came in, if there's a minor fail for the print job, like a missing line or area, is there a way to restart the print at that specific missing point? Yes, after your print is complete, you can select any feature that is missing for reprinting. So Nova will finish printing that specific feature. There is a pause button that we'll see a little bit later, where if you did notice something, you would be able to pause the workflow, but it would pause after the specific feature has completed printing. So let's head over to the software. Our first flow check has happened. And as you can see in the bottom left-hand corner, the camera comes into play to give us an image of the flow check. So once again, it is supposed to be 3 printed lines. We got 2. So we're going to go ahead and check one more time. So we did do a second flow check there. And as you can see, we do have 3 lines that are clearly visible. I was looking for a little bit more pressure to have slightly thicker lines. So I might increase this just a little bit more, and we'll do one more flow check. So we'll head back to the software to see what that specific flow check looks like. And that looks a little bit better, more what I was trying to achieve. So this quick menu here will just help you quickly calibrate the settings of dispense and relief pressure in order to get your print settings to where they need to be. Now, I already pre-calibrated this material in our calibration workflow. We won't go over that today, but there is a great video on our YouTube channel as to how our calibration works. And I would encourage everyone that is interested in learning a bit more about that to visit our YouTube page and check out that specific video. So we're going to go ahead and move forward now that we've done our flow check and we're happy with the results to actually printing our design. Now, I don't need to print the fiducial points here, so I'm going to go ahead and just click and drag along the rectangle because that's the only feature I want to print for this specific layer. And we're going to go ahead and hit start. Do have a few more questions that came in. For PCBs, I've seen 3 fiducials recommended. Are 4 fiducials typical for Nova? A minimum of 2 fiducials is recommended for alignment. Depending on how large the print is, I would recommend using more. Another question that came in is how to print two Gerbers on one layer simultaneously, one on the top and another on the bottom. So you will need to load each Gerber file as a layer in Plan. This will allow you to print the first file on the bottom and the second layer on top. So once again, utilizing Plan for a scenario like that. Okay, our print is complete, or our second layer print is complete. And we can go ahead and move on to inspect this specific design. So the camera comes into play at the end of the workflow as well, where we get to inspect. All right, and we can also change the increments here of how we'd like to move, or we can just click. So we can see that that layer did account for the height changes and printed quite evenly. There was a little bit of missing ink here, and that would require me to just increase the pressure and try again. But overall, the height map looked really good. It didn't drag against that first layer, and that's exactly what we were looking to see. Okay, so this concludes the second layer print, and now we're going to focus on doing the third. So the next step here would be to remove the substrate and now go cure the specific material and then bring it back for the third and final layer. So we're going to go ahead and hit next. We'll give it a thumbs up and we'll hit finish. When you hit finish, the vacuum table will go on. As you can see, the substrate is now easy to move. And we would go ahead and cure this. In preparation for the demonstration, I have already have the second layer cured, and we'll go ahead and focus on printing third. Okay. Okay, next we'll move on to the, once again, going back to the dispense workflow, because now we're going to be printing our third and final layer. So we're going to load the job here, our webinar project, and we're going to select layer 3 this time. And we're going to hit next. So we can see here that the third layer has loaded into the center of the workflow once again, and we're going to go ahead and align it similarly to what we did on the second. So we'll select our materials, our substrate, hit next. The film is already mounted along with the vacuum table. And the substrate is secured. The pivot point we're going to leave the same because we do want to align to that specific point once again, and we'll hit set pivot position. I'll zoom in on the software here so it's not so blurry for everybody. So once again, the camera is going to center itself on the XYZ. Another question that came in is, what is the minimum resolution between two printing? Our minimum trace width of 0.1 millimeters. Our minimum trace width is 0.1 millimeters. The smallest we've printed in-house between traces is 50 microns. Okay, so our camera's finished aligning on the XYZ, and now our design is going to populate in the center here. And once again, we're going to move our design to the bottom left-hand corner. So I'm just going to click in that specific area using the menu in the bottom left-hand corner. And it looks like I went a little too far. And let's bring this point right there once again. And here we'll make some small adjustments to just make sure we're in the center of the fiducial and that everything looks good there. And we can see at the top here that this one's slightly off, and this is probably due to the rotation of how I place the substrate. I can see that it is slightly off. So we'll go ahead and hit set rotation, and we'll make some small adjustments here to just make sure we are centered. And that fiducial is now right on top of that dot as well. So we are ready to move over to the next step. So once again, we're going to skip the tune alignment because it's not necessary in this for this specific design. And once again, we want to make sure our calibration plate is clean. Now we know that it's not because I did a previous flow check. So what we're going to do is we're just going to pop the calibration plate out, and with some IPA, I'm going to do this off camera. With some IPA, we're just going to quickly clean that with some IPA and some wipes that we have here, and then we'll just pop it back in. Nice and clean. Heading back over to the software, we can see that the probe points for this specific layer have also been populated in these white dots. We're going to go ahead and hit probe. So similar step here, the probe will come into contact with the XYZ. And why don't we check in on the questions that have been asked? What information, one question that we had here is what information is saved and transmitted online when using Plan? The answer to that would be the design files, generated toolpaths, and the probe point locations are saved into the cloud when working with Plan. Another question that came through here was, can the PCB height estimation tool be used without Plan? Without using Plan, can it be used exclusively to measure the thickness of the deposited ink? The height probe currently does not have this functionality. Another question here is there a way to adjust the thickness of the ink? Final ink thickness will depend on the specific material used, dispense pressure, print height, and nozzle diameter. I would even say print speed is another one that we could add. You cannot directly set the final ink thickness with Nova. It will require some testing to determine for each material. And this is where a good understanding of the materials you're working with, viscosity, particle size, nozzle that you want to use are all going to come into play to determine the right thickness for your material. Okay, so we can see that Nova is going to probe that that second layer, I should say, in order to print the third. Once again, on the software side of things, we do have a progress bar along with Nova in real time indicating which probe points have been measured. And like I said earlier, we did decrease the probe pitch here to account for the layer height changes. And so there are quite a few probe points for this specific design. Of course, if you can imagine if this design was 3 or 4 times the size, the amount of probe points that there would be. So something to consider, of course, when working with larger designs. Okay, the probing has completed. So we're going to go ahead and move forward. The dispenser is already prepped and ready to go. So we'll hit next. And we're going to do another flow check just to ensure that we have material flowing once again. Some other questions have come in as well. I'm concerned with printing on fabric, and I have faced limitations mounting fabrics and calibrating the probe target. Yes, printing on fabrics is something that is a highly sought after application and can be quite difficult depending on the specific textile that you're using, the porosity of the material, as well as how much it compresses during the probe targets, during the probing stage. But what you can always do is reach out to support at Voltera or sales at Voltera for any questions and potential feedback that we might have on these types of applications. Another question that came in here, I probably missed the point from the first 5 minutes, but is Nova software running in a browser hosted locally by Nova, or is it a standalone on the computer? So Nova can be used in both an offline and online mode. The Plan feature does currently require an internet connection as computation happens in the cloud. Okay, so our first flow check has completed there. We'll head back to the software just to see what that first flow check looked like. So once again, we do have some material has been laid there. I'm going to go ahead and once again increase the pressure just to get a bit more material to flow out for this third and final layer. So I'm opening up that menu and just increasing that dispense pressure. Once again, a photo will be taken. So let's see how this flow check turned out. All right, so we can see we have slightly thicker lines there, which is exactly what I was looking for. So we can go ahead and move on to the third and final layer print. So I don't need to print the fiducials. I just want to focus on printing the specific design. So we'll go ahead and select all and just control and click on the specific fiducials that we don't want to print and hit start. Okay. Another question that came in here, is it possible to reduce the force the calibration tip uses to height map our samples? Because we noticed that it leaves an imprint on the sample if they are thin layers of deposited material. Unfortunately, at this time, you're not able to adjust the probing force or sensitivity. Fantastic, that third layer is printed. So now we can go ahead and inspect it. So we'll hit next on the software here. Our camera will come into play and we'll head over to that specific direction to see how it turned out. So once again, we can see our third and final layer printed. The alignment worked out very well. It's exactly where I positioned it to go. And the height map was accounted for properly in printing this third and final layer. So this was a successful print, both for the second and third layer. And that is how you utilize Plan to print multi-layer circuits, both on flexible and stretchable substrates. We'll go ahead and hit next. We'll give that a thumbs up there, and we'll hit finish, and you're back at the main homepage. Now, like I said, I did say we'd leave some time for Q&A. So please continue to ask your questions in the Q&A box, as we still have quite a few more minutes that we can stick around. And as promised, here is the discount code as well. For Nova, you can contact our team here at sales@voltera.io for a quote, and we'll make sure to add the promo code for that specific quote. Another question that came in here, does Nova have any capability to print with a dielectric ink, or are only conductive inks supported? No, we do support dielectric inks as well. We actually have some options on our store. So all the nozzles both from Norson and Subrex, so conical nozzles, straight barrel nozzles. We have empty cartridges. Any consumable that you saw in the presentation here is available on our store page, and that includes a variety of inks as well. Another question that came in here, I'm looking for inks that can maintain conductivity after bending for applications like RFID antennas. Once again, we do have many flexible and stretchable inks on our store available for purchase. You can consult the technical data sheets. That's always going to be your best case for information to get those type of details. Another question that came in here, do we need to cure the ink after the first layer printing? Yes, you should follow the curing instructions on the technical data sheets for the specific material that you are using. And we'll have for the materials that we have in our store, we do have all the technical data sheets available, which indicate how to cure them properly. But yes, it is recommended to follow those steps after the first layer. And that's why we recommend having fiducials, because you will need to remove the substrate, put it into the the oven, bring it back, and then you'll need to align that second layer. Another question here, will we have a webinar on the V1? Yes, we have multiple webinars planned for the year. The V1 will be included in that list. The next one actually for the V1 is in May. So more information will come out on that in the coming months. We do have some previous V1 webinars as well on our YouTube channel that you can view, the most recent one being solder paste dispensing using the V1. So yeah, you can definitely check those out. What is the most conductive ink provided for Voltera is another question that came in. We offer many conductive inks that have been dispensed with Nova. The right ink for your project will depend on the project properties. Once again, you can check out our store and look at the technical data sheets to understand a bit more about the materials. Another question here. In terms of the inks, how viscous must inks be in order to work well with the Nova nozzle? Could it deposit pre-polymer solutions that are very non-viscous or even dissolved in solvent when the user could perform photopolymerization with a floodlight or cure chamber? So we do support materials between 1,000 centipoise and 1,000,000 centipoise. And then when you look at data sheets, anything that'll say meant for screen printing applications or a screen printable material is usually a good indication that it'll work well with our system. Another question here. Hey, all, thanks for the fantastic tutorial. Could you let us know what the best method is to clean the FlowCheck pad? Yes, the best way to clean the calibration plate is by using a lint-free wipe and then wet it with isopropyl alcohol, which is what I used to clean it when moving from the second layer to the third layer. And it is a best practice that when you're done printing that you do that right away. The paint is quite easy for it to come off, but if you do leave sometimes conductive materials or any other material, it may dry on there and you might require some other solvents to remove. So always best to clean up your calibration plate as soon as possible. What would be the feedback of the flow check? So during the flow check, you are looking for the ink output. Essentially, you're ensuring that the nozzle has been put on appropriately, that you don't have any clogging happening, and you're looking for steady flow. That'll just ensure that by the time your flow check is complete and everything looks good there, that you have the right flow for your specific design moving forward. Another question that we have here is how does the ink get cured? So we use a standard box oven. So most inks are thermally cured. There are UV curable materials out there as well, but we do have a standard box oven here at Voltera to cure the materials that we sell on our website. Another question that came in, can Voltera print multi-layer circuits using Gerber files if requested? Also, do the designs need to be modeled on plan before printing? So Plan definitely helps for multi-layer designs. It's recommended to use Plan for multi-layer designs. You are able to load your entire design to see how the layers would stack up and superimpose on top of each other. And once again, the other added feature of using Plan is that the probe targets, when generated, will keep into account the previous layers and accumulate more in those areas where there's going to be layer height changes. So another benefit of using Plan. Can we use Nova offline due to disconnection problems, which is very annoying in offline mode? Do we need any type of internet? Because as far as I know, Nova software needs to be browsed on the internet. Nova does have an offline mode. As mentioned previously, general dispensing and ink calibration can be done without an internet connection. At this time, the plan feature does require an internet connection, but potentially more updates on that in the future. In the future, would it be possible to have the functionality of Plan as a standalone app? That way users sharing a Nova system can prep their jobs beforehand rather than as they're using the machine. That's a great question. Matt who's answering the questions here, said, "Thank you for the feature request. We'll make sure our production team can take something like this under consideration." How do I make sure that, another question here, how do I make sure that the second or third layer printing does not damage the previous printing due to height changes? I guess the concern here would be that the tip might damage the printing. So Plan generates these additional probe points for additional layers. These additional points allow for more detailed height mapping so that there are no nozzle collisions with the existing feature during dispensing. And that's where you would have saw in the Plan feature those specific probe points accumulating together at the points where they intersect with each other in the layers. And having more probe points there result in a much more accurate height map, ensuring that the nozzle won't crash into any existing layers. Okay, it looks like all the questions have been asked and answered. Once again, thank you so much for your time and thank you for joining us for our first webinar of the year. As I mentioned, there will be more that will be planned, so please keep a lookout in your email for more news on those. Our next one will be coming up shortly, and more information will be released on that. Once again, thank you again, and have a great day.